I just finished this sculpture and I really like it, so let me tell you about it. It's called Whimsy. It's about 10 inches in diameter, made of cherry wood. It's very simple and yet very confusing at the same time. There are 60 identical parts. Each points in a different direction and lies in a unique plane, but you can see there's also a logic to its craziness. I like that it isn't quite convex, but the pieces are flat and the individual corners look like it should be convex. How does that happen? Well, the underlying ideas are about symmetry and the geometry of forms arranged in space. As a mathematical sculptor, my job is to take these ideas that were just floating around in my head and somehow make them physical for others to see as well. Then there's the engineering challenge of how to make the parts, what material to use, and how to join them together accurately. I decided to laser cut the pieces from cherry. To position them for gluing, I 3D printed this special jig with the correct angles to hold the pieces while I glue them. I've already sanded the faces of the parts and applied a tung oil finish to all surfaces, and I've beveled the edges so they'll mate at the correct dihedral angles. I'm applying glue to just the beveled surfaces. Using a brush lets you get it everywhere you want into the texture of the wood and lets you control how much glue is applied so there won't be gobs squishing out after you clamp the parts together. Clothespins are handy to hold the parts to the jig. I've sanded down the tips to give me the grip I want. I can place 5 parts around a 5-fold vertex and use the jig to ensure the other ends of the pieces are precisely positioned like a regular pentagon. I made a second type of specially modified clothespin to hold the surfaces together. Making custom jigs and clamps like this is the key to assembling many of my sculptures. I enjoy the puzzle of figuring out what tools I need to make along the way to making the end products that I really want to make. I can make these 5-fold modules one at a time on the jig, and when I have 12 finished, I need to fit them together. They meet 3 to a vertex, like a regular dodecahedron. No special jig is needed here, because I can just use twist ties to hold them together. So you see, the openings in the pieces are not just for aesthetic reasons, but they're also a key ingredient in the assembly process. Putting the modules together is then pretty straightforward. You may be wondering where the crazy angles come from and how each of the 60 pieces can lie in its own plane. I based this design on the pentagonal hexacantahedron, which is a Catalan polyhedron with 60 identical irregular pentagon faces. The 5-fold vertex of the sculpture comes directly from the 5-fold vertex of the polyhedron. But I designed the sculpture piece shape to extend beyond the pentagon and meet in the air above the 3-fold vertex of an adjacent face. The result is that there's a simple logic to the design, but it's not obvious when the underlying polyhedron is removed. After a lot of work, I finally have my sculpture. I'm so happy it's exactly what I envisioned, with just the right mixture of geometry and whimsy. Like a child, it's the only one in the universe of what it is. So it's very gratifying to be able to bring it to life and share it. I love this process of thinking of a design, writing software to help me visualize it, doing the math to work out the lengths and angles, selecting a material in which it can exist, engineering how it will be assembled, making custom tools, woodworking, laser cutting, hand finishing, and putting it all together with the care worthy of a unique work of art. And I hope you like it too.